Recording is on. So first one, this is use a rule in orders of operation. So orders of operation is, I love people that talk, PEMDAS, right? PEMDAS or GEMDAS. I will not understand GEMDAS because I was raised in a different time. So we're looking at this, and first of all, we're looking for parentheses. Well, we've got one set of parentheses here, but we got a second set inside of it. So we start the process over again. We see that. I want to look at here. I have no more parentheses in here, but let's see. Do I have exponents? No. Do I have multiplication or division? Yes. Suddenly, take this. 5 times 2 is 10 minus 14. And I'm still inside the parentheses, but I've done my multiplication. There's no division. Addition, nope, subtraction. So 10 minus 14 will be negative 4. Negative 4 stays on the inside. We have a 6 on the outside, plus, uh-oh. Oh, no, don't start this already. It does this a few times, sadly. Yeah. That's why whenever you say you hope for something to not go wrong, it's still going to go wrong. But hey, at least it saves that much of it. So, negative 4, 6, plus 7, and then there's your bracket. Okay. It's just deleting stuff behind me at this point. Yeah, I'm clearly being very forgetful. I thought I did that. Okay. Times 3. So at this point, you go inside the brackets again, looking at parentheses, and then we say, well, there's no exponents, there's multiplication, so we're going to do 6 times 4, and that's going to end up giving us 24, but it's going to be negative 24. So don't start doing this on me again right now. That's a really bad looking 7. So let's do that better. Yeah, it would be nice. So now we're looking at this. We still have parentheses here, so we're going to look at it again. No multiplication, division, addition, subtraction. There's subtraction, so we're then going to subtract 24 from 7. It's going to give me a negative number, negative 17, if I'm right? Yeah. Negative 17 times 3 equals, well, let's just, over here, 3 times 7 is going to be 21. Put the 1 down, carry the 2. 1 times 3 is going to be 3, 4, 5, 51, so negative 51. All right, so it's the first one. No more glitching, please. Goes question number 2. Add using the rule of order of operations. So we're going to do those again. PEMDAS. Okay, so parentheses. There's a lot of parentheses here. So this is a set on its own, and this is a set, and this is its own number. So looking at this, we've got 1, 2, and 3 sets. Let's start with the first set. So negative 12 plus negative 11. So, yep, negative 23, because we're subtracting 11 from a negative 12 already. That makes negative 23 plus 3 plus a negative 4 would be negative 1, right? So that is going to be negative 1 there inside that parenthesis, and then plus a negative 8 in its parentheses. So at this point, we're doing addition of all of them, or technically subtraction, because it would end up being negative 23 minus 1 minus 8. This would be negative 24 minus 8. And that would give you negative 32. All right? Haven't lost anyone yet? Question 3, evaluate. So when we evaluate for a variable, that means every time we see that variable in that equation, we're going to replace it. So then we're going to do negative 3 in for the c squared minus 3, negative 3 plus 5. So now that we have put the negative 3 in for each c value, we're now going to use PEMDAS. We use PEMDAS. We first of all look at it and go, are there any parentheses? Well, technically these are parentheses, but This one says multiplication, that one says exponent. So exponents is greater, so we're going to start with there. So we'll do negative 3 times negative 3, which makes a positive 9. 9 minus 3 times negative 3 plus 5. Next part here is we're going to do a multiplication. Negative 3 times negative 3 again is 9, so it'll be 9 plus 9 plus 5. Now I'm going to hopefully move. Yes. 9 and 9 becomes 18 plus 5 equals 20. What? You said 22. 23. Pretty good guesstimation you got there. All right. Question 4. All right, so solving for this one, we have both x's and numbers. So our whole goal is to get all the x's on one side equaling all the numbers on the other side. And that will be how we get our answer. So we also have here a 7 distributed to both an x and a 4. So I've got to do that part mathematically before I go anywhere else. So we're going to go 10x minus 4 equals 7x minus 4 minus 1. Distribute these here. So it'll be 7x minus what? 4 times 7 is going to be 28 minus 1 equals 10x minus 4. Now here's my tip. Whenever you're looking at two positive x values facing each other, always move them towards the bigger one because it's going to keep x positive. That way you don't have to change all the signs at the end of this. So that means we're going to move the 7x over to the 10x. And that'll leave us with a positive end x result. That's what we always want to look for. So because we're going to do that, we're going to subtract 7x from both sides. These will cancel out, and that'll leave us with 3x minus 4 equals, and we're just going to make that 29. Bless you. All right, so at this point, we're going to still get the numbers away, so we're going to move them over. We're going to add 4 to both sides. When we add 4 to both sides, it'll be 3x equals negative 25. Yep. Something's going to look right here. All right, we'll keep going with that, though. At that point, we'll have to divide both sides by 3. And it'd be x equals, I don't think there's a way to simplify that. We went wrong somewhere.
Yeah, in the beginning, well, I'll just continue.
Yep.
I solved it another way.
Yep.
I could be wrong. That's the way that
Okay.
So in the beginning, I added 4 to negative 4 on the left side of the equal sign.
Okay.
I added 4, and then I added 4 to the negative 1. So I canceled out the negative 4 on the left side, and I turned the negative 1 to a positive 3. And then for the second step, I subtracted 7x. Giving me 3x equals negative 28 plus 3. Then dividing both sides to isolate the variables, and that's what we have x equals negative 28.
This is following the orders of operations. That's where you need to remember PEMDAS and work through it that way, because the answer is the negative 25 over 3. I wasn't sure if we were doing fractions yet or not, so I had to check the notes. But yeah, in that case where you're going wrong is moving your 1 and your 4 and trying to make it to a 3. Because this ends up being a positive 4 no matter what you do on that side. It would be the same as saying this is a positive 1 over here, which would give you a positive 5 rather than a 3. That's where that part's on. How you doing today, Mr. Russo? I'm just doing this review. The answer is negative 25 over 3. I think I have some of your students over here today.
Yeah, me.
All right, so next one, we're starting off with decimals. Now, I know we don't like decimals, but these ones that should be simple is what we're doing. So in this sense, remember how I said we want to put an x on one side and we're going to equal the number on the other side? Well, we only have one x this time, so we don't have to worry about moving all the x's to one side. but we got to get stuff away from it. So if we know that we're looking for it to be 4x equals, we're going to have to subtract the 6x, or 6.4 to the other side. So that would be 26.4 minus 6.4. So
we're subtracting 6.4 from 6.4, right?
we're subtracting 6.4 from 26.4, which will end up giving us 20 because they gave us perfect decimals. And that equals 4x. You will then divide both sides by 4, and that'll give you x equals 5. And I did mention this with PEMDAS earlier, how we're still following PEMDAS, but when we're deconstructing an equation like this, we do what's called a reverse PEMDAS, where we do the subtraction and the addition first, and then we do the multiplication and division. So we subtract away, or we'll add away items from the x value, and then we'll multiply or divide away from the x value to give us our answer in the end. So it's only when you're trying to isolate a variable. For example, we're isolating the x here to know what the x is equal to.
Okay.
All right, we good?
Yes.
All right, so solve for answers, introduce or reduce fractions. So we can do a bunch of fraction math here, or we can get rid of all the fractions. Do we like getting rid of fractions?
Yes.
So when we're getting rid of fractions, we've got a 1/4 and a 1/3. What would be a common denominator? 12? Okay, so if I was to get rid of the 1/4, then I would multiply it by 12, so that would be a 3, right? So it has to be 3x, and then 1/3 times 12 would be 4, right?
Yes.
4 equals, and then 1 times 12 is 12. So all by multiplying the entire equation by 12, which was the least common denominator, LCD, we then knew that we don't have to deal with fractions. They're gone, right? No fractions here. So now we're just going to subtract across our 4, because remember we're doing our subtraction and addition before our multiplication division. We get 3x equals, 12 minus 4 gives you 9. Brain check, 9, 8, I'm being a goofball, 8. And then we're going to end up dividing both sides by 3. We'll end up with x equals 8 over 3, because we cannot simplify that anymore, because we have a prime denominator. We doing good with that one? Whenever you see fractions like that, you can just multiply everybody by the same number and just get rid of the fractions, because we don't like fractions.
We don't.
All right, so areas, lengths, widths, perimeters. First thing is, whenever I get word problems like this, I like drawing out things. This is the width, this is the length, and the perimeter is just both width and both lengths put together. But they want us to solve for L. So if we have this equation, P equals 2L plus 2W, they want us to have it so the L is alone. Now with this, we're going to do the reverse PEMDAS because we're isolating a variable, right? So we're going to do which parts first? Our addition and our subtraction. Can I add or subtract something away from it? I can subtract away the 2W. Subtract 2W. Hey, do that too. There you go. So P minus 2W equals 2L. At this point, I've added or subtracted away. Now I need to multiply or divide. So I'm going to divide away, and we're going to divide both sides by 2. That's going to give me L equals, hey, stealing my stuff. Alrighty. Got just don't even, I'm just going to start that whole area again. Minus 2w over 2, which will, no, don't do that. Technical difficulties are always fun. Cancel out the 2's. L equals P minus 2w over 2. If you were to write that on a computer, or you want to write that properly, you'd put parentheses around P to W, saying that whole piece is over the 2. Some people will simplify it further, and it would be P divided by 2 minus W equals L, because they simplified the 2, W, and the 2, and they left P over a 2. Actually, P 2W over 2 is the proper answer, but this technically will also work because they just simplified it a step further. But it's not required for areas and perimeters unit metrics. And number 8. All right, so now we're going to be solving inequalities. So this cool thing I like about inequalities that people don't like is there's that little sign in the center that does flips whenever you multiply or divide by negative numbers. So unless we do that operation, it's going to stay the same, right? So I'm just going to make a line here. Every time that we multiply or divide by a negative number, we put an X there. So we suddenly know it flipped. So we're going to look at this and we're going to say, well, we want to get all of the X's over to one side, correct? So we're going to go to the larger side. So that means we're going to move the 2x over with the 3x. So we'll subtract 2x from both sides. Since this isn't division, it's subtraction, we haven't flipped the sign. So we're going to end up with a 4, some item, equals, since we're doing 3 minus 2, it's just going to be an x plus 1. At this point, I want to get the 1 away, so I'm going to subtract 1 from both sides. I end up with 3 sine x. Now, if I look over here, I never change the sign, so it'll just say 3 is greater than x. If I divided by a negative number, we would have flipped it. And however many times we divide or multiply by a negative number, we will flip it that many times. Every time that you multiply or divide by a negative number, you'll have to flip it. Each time. It's not just once. Every time that you do it, it's like a light switch. We're going to maybe see that in the next question, I think. Yes. See, we're actually going to see it in this question here. So we're looking at 4 different drawn-out options. But what we want to start with is solving the equation down to an x is greater than or equal to, or x is less than or equal to some number. That way we know exactly where it is. I'm guessing it's going to be 3. Guessing it's going to be 3. Just don't know which side of the 3 we're going to be on. So, negative 6x minus 4 is less than or equal to negative 22. The first thing we're going to do, since we're doing reverse PEMDAS still, because we're trying to find the variable, right? We're going to add 4 to both sides. Negative 22 plus 4 will be negative 18. Still, is y. Okay, good. It's back. Equals negative 6x. So at this point, I will be dividing both sides by a negative 6. This is where we flip the sign. So now, because we divided by a negative number, we're going to flip the sign to being greater. So it'll be x is greater than or equal to negative divided by a negative makes a positive, and since it's 18 by 6, we'll get a 3. Right, either one. So looking at this, I know that x will be greater than or equal to 3. Well, we've got 2 answers that are greater than, showing down here. So that automatically tells us that these 2 are out. Now, does anybody here know how to tell the difference between open and closed dots? Robots and owls. So we know robots and owls? You've heard of those? Okay. So a quick just review for the people who aren't here right now that are on the internet. An owl has big open eyes, and it has a little beak, and it has these big fluffy sides. Come on. Yeah, he flew away. Well, parts of him did. Okay, so this would show you you have an open hole, and that is a greater than or less than sign, and then you use parentheses when you're doing set builder notation. On the other hand, if it's equal to, you'll have a little beady, just going to keep taking away my stuff, beady eyes, weird extra mechanical pieces, and these like tank treads. That's how I look at them. And that's going to be your closed dots, your greater than or equal to signs, less than or equal to signs, and your brackets. We know this because robots are very precise. They'll go right up to the point, and they'll actually touch the dot. Owls, on the other hand, they're fluffy creatures. You can poke them all day, and you're never going to touch them. They're just going to dodge right out of the way, like a cat. I just cannot win with this. I cannot have my art, can I? Okay, I'm done trying to do that. So since we know that it is greater than or equal to, we do know that it's going to be a closed dot, and that's what tells us that the answer is number 3, and more stuff keeps disappearing on my wall. But we can also do, in this one, theory-wise, we can do process of elimination. Knowing that it was a less than or equal to, or greater than or equal to, automatically takes both of these ones with the dots out, and then once you figure it out, if the sign flipped or not, you would then know which direction you're going. So that's the shortcut way of doing it, but you should at least do the math just to make sure. Rectangular room is twice as long as it is wide, and its perimeter is 42 meters. Find the length of the room. Who here doesn't like word problems? Yeah, that's about everybody. Yep, I completely agree with that. So we're going to draw it because we really like drawing things, okay? So you draw it, and it says that the room is twice as long as it is wide. So that would be 2W equals 1L, correct? What's wrong? Okay? Okay. So we're going to do that versus our W. So at this point we know that the great perimeter equation is P equals 2L plus 2W. That's a really bad oops there. Okay. So at this point, the issue is I do know it's 42 meters, so I can put the 42 there, and I still have 2L plus 2W. The problem is there are two variables, and you can't solve for a variable if there are two, because they could equally inverse each other to be different things. But we do know one variable in terms of the other. So this is kind of like systems of linear equations where we will take one and we'll substitute it in for the other. Because we know what L is equal to, we're going to end up saying 42 is equal to 2 times 2W plus 2W. The first two, what?
Would you use the distributive property to multiply 2 times 2W?
Yes, we will distributively.
Would you distribute that 2 over?
No, because it's the only part in the parentheses is the 2W. For example, if this had said that the length was 8 feet longer than the width, then I would have written instead of 2W, it would have been L plus 8. And when I had it down here, it would have been 2 times L plus 8 plus 2W. The 2W on the end is not going to be a part of the distribution, but both the 8 and the W would be a part of it.
Okay, so would it be safe to write 2 open parentheses 2 times W, just so that the distribution would be more clear? Like, would you just, like, for example, 2 times 2 and then 2 times W?
Well, no, because it's going to end up being all the... I have 2 W's right now, and I'm just doubling that, so that'll give me 4 W's. So I'm only multiplying the two coefficients together technically. So you end up with 4W plus 2W on the end, equaling 42. I try my other marker, see if that works.
So you went to 2 times 2?
Yeah. I did to get the 4W, but I'm having a hard time here drawing right now. Technical errors. Let's try this one. Are you going to stay? Okay, good. Then we'll end up adding the 2 and the 4. Okay, can I? Thank you.
Yeah.
42 equals 6W. At this point, we'll do our division, both sides on 6. And we get W equals 42 divided by 6 is 7? Okay, 7. And I have my answer, right?
No.
Oh. That's right. That is my width. We're looking for the length of the room. Since we know that W equals 7, and the question is to find the length, we'll just plug this in to the equation. 7 times 2 equals L. 14 equals L. We know the length is 14. Always go back and read your question because it's never fun when you get it wrong just because you've misread the question. Latex paint sells for $25 per gallon and will cost you $110 to paint your room. If each gallon will cover 210 or 220 square feet, how many square feet of wall space do you have in your room? This is a properties equation. So we're going to write these as, the latex paint sells for 25 per gallon. So that'd be 25 for 1 gallon. And it'll cost you $110 to paint your room. Well, not yet. That's where we're trying to draw this out. If each gallon will cover 244 square feet per gallon, right? Square feet. Cover square feet. So taking this by square feet, 110. Right. So my brain is facing out. Give me one moment. I just don't want to do this one backwards in front of everyone else. It's a ratio problem. It is, but I'm just making sure that I'm doing it the right way because I'm very well known for doing these ones the wrong way. 25. Doing long division. Doing 2. Okay, so we know if it takes $25, you're going to divide 110 by 25. Sounds like my students are way ahead of me on this. And that would be 4. Does it end at 4? 4.4? Yeah, 4.4. All right, so if it's 4.4 is how many gallons you're using, then you're going to multiply that by how much square feet each gallon is going to give you. So then you'll do 220 by 4.4. We're just going to ignore the fact that we have a decimal for right now in long division. 4 times 0. 4 times 2 is 8. 8. Add 0 there. And then you go just copy the same thing. What? Yep. Oh, here. Let's. Happy? Okay, good. We're happy. Now then we're going to add them together real quick. 16, put 6 here, carry the 1, 9. And remember, since we moved 1 decimal out, we move 1 decimal in. That gives us 968 square feet. Why? Congratulations. Give me back my program. Oh. Everybody help me on that last bit. 6, 9, moved in because we moved out. And then we'll do 9, 6, 8.
You only move your decimal in how many, when you're multiplying, how many spaces. So
For which way?
it on the outside, you only move it to the left once.
Right.
Because, so in your answer, you do the same thing.
Well, no, he's talking about when he did his long division, he got 4.04.
Oh.
Which, we'll go back over that later. I don't know how. Probably zero adding is a very big factor, yeah. All right, so, hey, we're actually making good time on this. All right, so find the area of a rectangle with length 25 meters and a width of 13 meters. So, we're going to draw our box again, right? Do we know the equation for this? Length is, look at that. We got someone who knows it. Area equals length times width. And we're looking for the area. So, we know both the width and we both know the length, so we're just going to end up doing 13 times 25, and we're just going to do this as multiplication as best we can. 3 times 5 is going to be 15. Put the 5 down, carry the 1. 3 times 2 is 6. Plus 1 is 7. 1 times 5 is 0. Put there 5. 2, 250 plus 75. 5 carries down. 2 there, carry the 1. 3, 325. So the area will be 325 square meters. And that's how you would do it.
Everybody good?
Would that be the same as writing 25 squared meters, right? Like with the symbol?
Yes. Certain places it doesn't always hold true because everyone's got their own way of writing things. So you have 8 different ways to write the same item. So you could put the squared up here technically and then do the meters down there. Or people do SQ meters, or there's SQRT. Like there's several different ways to do the same like answer right out. I say always put your measurements there if they give you measurements. So technically you're always right. Some people say you don't need to put the measurements, but you could be talking about inches, centimeters, miles. You don't know at that point. Come on. Find the area of a triangle pictured below where the measurements are given in meters. All right, so because we have, let's say, an imaginary square here. Well, no. Okay, so I'm turning this into we're doing. Well, he was talking about hypotenuse because he thinks we're going to do Pythagorean theorem, but we're not. So technically, every triangle is just a square, but it's half of it. So the math for the area of it would be equal to the length times the width, but also times 1/2, because it's only 1/2 of the area. This is also known for triangles as A equals the base, which ends up being one of the arms, times the height times 1/2, this being the height. So if that plugs in, then we'll do 5 times 6 times 1/2. So we'll end up doing 5 times 6. We get 30. Still times 1/2. So technically 30 divided by 2. Yeah, but again. So then you end up with 15 as your area. So it'd be 15 SQ meters. 15 square meters is your answer at the end. Do we get how we got the area of the triangle? I mean, it'll always work that whatever the height of the triangle is, no matter where it is, times the base measurement, times 1/2 will always work. But that's always because if you think about it, there's this giant square around it that you could just do the height and then just cut it in half. Retired couple invests $25,000 in bonds at a simple interest rate of 4.1. At the end of 1 year, how much interest did they receive on their investment? So there is going to be a formula for this. It's called I equals PRT, When we're looking at this, we're going to start filling in things. So the couple invested $25,000. Which of my variables is that $25,000 going to be? P, principal, yep. Even though it says invested, that's how much they put in at a simple interest rate of 4.1. So that means that R is going to equal 4.1. Trying to think that they move it back to being 2 zeros in front of it, don't they? For this one. No. Where is... I'm not reading the same thing, am I? Question 14, how long is... Alright, long multiplication. Okay, so yeah. Because this is a percent out of 100, we'll then end up moving the decimal place 2 parts over, so it'll be 0.041 is what we're multiplying by. And we know that the time, they said they only did 1 year, right? So it's 1 year interval of time, so 1 times anything. We know the principal is being 25,000. All equals how much interest at the end of the year. So the 1 multiplied by anything is 1, or anything times 1 is itself, so we don't even need the 1 to be there. Yep. Because when we did it as 4.1%, we had to move 2 decimal spaces out because it's a percent, and we're trying to deal it with regular numbers. Right, so it's over 100. So then at that point, we're going to do basically a long multiplication, 25, 0, 0, and we're just going to do it as 41 right now, knowing that we moved out 1, 2, 3 decimal spaces. 0, 0, 0. 5, 2, and then we go 0 as a space holder, and then go 1, 2, 3. 4 times 5 is 20. Put a 0, carry a 2. Four times 2 is going to be 4 times 2 is 8, 9, 10. So we're going to put 10 there. And then we're going to end up just adding these, so it'll be 1, 0, 2, 5, 0, 0, 0. But if you recall earlier, we moved 1, 2, 3 spaces out. So we moved 1, 2, 3 spaces in, giving us $1,025 equals. Okay. I would love to. This is all from taking the numbers that we had and plugging them into the formula and then figuring out what our own variable was, isolating it, and then doing all the rest of the numbers together. All right? This will always be, whenever you hear money, it's probably that equation. Unless it's the ratio of money, which then you're just doing cross multiplications. You'll see that later. Anyways, going to question 15. Speaking of which, there's the ratios of money that we were talking about. Christy categorized her spending this month into 4 categories: rent, food, fun, and other. Percentages she spent in each category are pictured as below. She spent a total of $1,600 this month. How much did she spend on fun? She knows that she spent 17% of her money on fun. So we've got $1,600. 17% can be seen as 0.17 in the decimal form because it's out of 100. So we have that there. We're going to move the decimal out 2 places, so it's 1,600 times 17, and then we'll start doing our math. 0, 0, 6 times 7 is 42. Put the 2, carry the 4. 7 times 1 is 7, plus 4 more is going to be 11, so that's going to be 121. And then we're just going to add 0 to 1, 2, and 1, because all that's multiplied by 1. Take it out. 0, 0, 2, 7, 2. Remember, since we moved 2 out, we're going to move 2 back in, right? So that means $272 equals per funds budget. I still want to know why the other is bigger than the fund. But anyways, that's how you would figure out that percentage. We good with that?
Other is like gas, toiletries, clothes.
Well, not food, not real. Clothes. That's some Prada right there. If you're spending $272 on fun and you're still spending more on other, that's some really high class shoes.
Yeah. Well, and then gas for your car.
Gas is only $2.09 right now. Hey, everybody listening to this video, it's only $2.09. Probably true. All right. Yeah. So question 16. If 16 is increased to 24, what is the percent of increase? Right. So there's a formula for percent of increase. Percent of increase equals first minus F minus I over I.
I know, it was amazing. I was just thinking, this is new.
It's also known as new minus old over old.
Oh, okay, I know that one.
So this also equals new minus old over old. Again, that's your whole GEMDAS, PEMDAS thing. People are taught it differently. No, that's if you're trying to figure out growth patterns.
Okay.
So right now we're just doing new minus old over old. So if it was new number is 24, so it would be 24 minus 16 divided by 16. Doing the math real quick, 16, 24. What?
Wait, like
What?
new, old, old?
Yep.
Okay, gotcha.
Over old. Yep, divided by O at the end. So when we do 24 minus 16, we end up with 8. And that is divided by 16. So we'll end up with, 1/2. So the percent of increase would be 50%. Yep. Now, on the other hand, if I wanted to figure out the percent of decrease in this solution here, so the percent, here, let me change the color real quick just so that you guys can see this better. So if I wanted to do the percent of decrease, it would be the same thing, where it's new minus old over old, but it'll look different because it'll be 16 minus 24 over 24, which would end up being negative 8 over 24, which ends up as, it's 1/4, right? Yeah, negative 1/4, so that would also be, you have 25%, and then you would say decrease, to make sure you understand it's negative 25%, okay? But that's how you would do the decrease instead. It's the same thing where you're doing new minus old over old, but you got to make sure that when it says negative, you know that that just means it's decreasing that amount. All right? It's the same formula. It works both ways, which is a good thing because then you don't have to memorize two formulas. All right, going to number 17. I'm going to change my colors back. All right, I can go pink. No, let's not go pink. Let's see. Sarah buys a DVD that costs $15 during its release week. If the price of the DVD is increased to $25 the following next week, what is the percent of increase? So again, this is percent of increase. So we're going to do new minus old over old. And that's going to be, since it used to cost 15, right, release week, and then increased to 25, so that'd be 25 minus 15 over 15, not 25. When we do the subtraction, 25 minus 15 is going to be 10. 10 over 15 ends up being 2/3. or if we're looking for that in percent, that would be 66.6%. I would put the 0.6 there just to make them understand it's a repeating decimal, but that's how you would be able to state the percent of increase.
Can you show how
Okay, so trying to think
3
how.
into 2, right?
Right.
Okay.
It's division of 3 into 2. You end up pulling out the 30, and then yeah. Next part of that is going to end up being 18. Find the y-intercept of the line represented by this equation. So does anybody remember the or not the y-intercept, but this? I gotta go. Yep, slope-intercept form. It's going to be y equals mx plus b in that form. This over here is not in that form, so we're going to have to change that around first. So first thing we're going to do is, remember, we're trying to isolate a variable here. We're trying to isolate y. So we're going to do reverse PEMDAS again. Back to the old stuff. That means we're going to subtract 4x from both sides. When you do that, you'll end up with a 3y equals negative 4x minus 20. Because we are looking to get y by itself on one side, we want to leave it alone the best we can. If it was negative, you would still move it over with the number in the end. So for example, if it was negative 3y, when you divide across, you divide across negative 3y, still leaving you with a positive y value. So you should never really move the y in this form. You'll move the numbers away from the y, you'll move the x away from the y. Everything's just being moved away from the y, because right. If there's y's on both sides of the equation line, you'll just pull them together on the one side and then move everything away from them at that point. But going forth now, we now have a division that we're going to have to divide both sides by 3. That'll cancel out, and we'll get y equals negative 4 over 3 x minus 20 over 3. At this point, let's see if we remember our parts here. So we've got our y variable. We've got m, which is slope, right? We've got our x variable, and then we've got this b. B is called what? The y-intercept. B is known as the y-intercept because when x equals 0, and that cancels out your slope, y will equal b. So it'll tell us that if I put in for 0 for x, saying that it's on the point or line of origin, that means that y will just simply equal negative 20 over 3. That's only when x equals 0. Because 0 times, no matter what the slope is, ends up being 0, and then y just equals b.
I thought over the I thought you had to do this.
No, because
took it away, you don't
when I subtracted the 4, because this is a 4x, right? That's just a regular 20. So the negative 20 and the negative 4x can't work with each other. So that's why. Okay. Yep. So, and it says write it in an ordered pair. So ordered pairs are written in parentheses x comma y value. Right. So in this form, when we're looking for the y-intercept, we're going to say 0 because we know x is equal to 0 and y is equal to negative 20 over 3. Close parenthesis. This is an ordered pair, and that's how we tell them that's our final answer. All right. How you doing? Don't worry, we've got a recording. And yep. 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 Yes.
And you divided both sides of the equal side by 3.
Yep.
Why don't you divide the entire expression, negative 4x minus 20 by 3? Could you have just divided 20, negative 20 by 3, or negative 4x by 3?
No, because we're looking at this as a balanced sense. I've divided this entire side of the equation by 3, therefore I must divide the entire side of that equation by 3. This is a balanced system. When you're looking at an equal sign, it's kind of like the scales. When you take a pound off of this side, you have to take a pound off of that side to keep it balanced. So no matter what I do to this whole side, I have to do to that whole side. You'll see that later on with radicals where we're squaring. Huh? Right. Right. I broke it down with the x because if there's no way to simplify either one of them, but breaking it down can help you look and see if there is. For example, if 20 was divisible by 3, suddenly I would know that, oh, I could bring it down. Say it was 21 over here, I'd know this would be plus 7 instead. So rather than writing this fraction, I'd write the 7. But again, that's just ifs, ands, or whatnots of it. But imagine rather than I'm doing it to both sides, I'm just to the entire equation itself. Like from this side all the way to this side, I am dividing the entire thing by 3. Like everybody gets divided by it. Nobody's excluded. Both sides, every party gets divided by 3. Okay? All right, so find the slope of the line that passes through the points. All right, so slope is the right word. So we're looking for slope. We're going to do what's called rise over run. The mathematical term for that would be either the change in y over the change in x, or we're also going to say y2 minus y1 over x2 minus x1. Now, this is where you got to keep your numbers very well put together. If this is x1 here, this must be y1. The numbers have to be the same. If you end up switching these, you're not going to get the same slope. If this is going to be x2, then this has got to be y2. And the cool thing is, I could have flipped those. The first one could have been the x and the y2, and the second one could have been the x and the y1. But that part doesn't really matter. What matters is you keep the 1s and the 2s together. So now we're going to take those numbers that we have, we're going to input them in this little formula we've made. Okay? So we have y2. y2 is a negative 16. So negative 16 minus a positive 12. So we're just going to put negative 16 minus 12. And for the x2 part, x2 is negative 10. So negative 10 minus an x1, which is a 6. So what I'll do here is called minus a negative. When I do this, I'll just put a line here, and I'll call it a plus. Okay? Because we're just doing a minus, so it's positive. We flip it. So when we're doing this, we're then going to go negative 16 minus 12 will equal 4. Negative 16, no, negative 12. So I'm adding the 2. Never mind. Hold on. Yeah, hold on. Okay. Yeah, negative 28 over, and then it's going to be negative 10 plus 6 will give us negative 4, and it's 28 divisible by 4. Yes, it's divisible, what? 7. So 28 divided by 4 will be 7, and because it's a negative 4 and a negative 28, it will be a positive 7. And we'll just do that with a little long division here. 4, 28, and you'll figure out 7 equals 28, so it just cancels through. All right, so 7 will be the slope that equals m. And just going back to it, the reason we know it is rise over run, so that means we're going to move 7 units up for 1 unit over. Okay?
So 10
plus 6 gives us a negative 4. Because we've got positive 6. So 6 good guys, 10 bad guys, 4 bad guys are left. Find the slope of the line. So when you're looking at a graph and you're trying to find the slope of the line, we're still looking at the rise over run. We could do the points. So say we know for a fact right there is a really good point. So we're going to find 2 points where it's exactly on dots. Yep, I like -2, -2, because that's actually a really good looking point. So I could do the math of it, -2, -2, and I'm going to do it just to help with it, and then it's going to be 0, 3. And this, if we do this as x, what? Really? Yeah. Make this appear. Write that again, okay. x2, oh, so. I'm going to write again, and we're going to hope it doesn't go away this time.
Oh, no. Go further to the right. Further to the right.
Last time it was my jacket. You guys made me strip my jacket last time, and that didn't help. So I don't want to hear it from you guys.
-2,
-2, -2. We're going to do it over on this side and just hope that it doesn't take it from me. We're going to go 0, 3. All right, who's flashing light on here? All right, so x1, y1, x2, y2. So let's do it that way. So we're going to say 3 minus -2, which...
Yeah, you're going to cancel that.
Cancel it out anyway. It is a -2 because it was negative over there. But since I did the minus sign, minus the -2, formula will say minus the minus is a positive. I just turned it into a +2 at that point. Yep. Yep, and we're going to do 0 minus -2, 0 plus 2. I know they're really weird looking plus signs, but at least you know that's how that works. So I'm going to go back this way. Hopefully it's not going to erase it. So 3 plus 2 is going to be 5, and then 0 plus 2 is going to be 2. So that means that our slope is 5/2. Another way to confirm this from the dots on the chart is I'm going to go 1, 2 positive, right? And I'm going to go 1, 2, 3, 4, 5 upwards, right? So I just say I moved 5 units up, and I moved 2 units over. And if you go the other way, it works the same because you'll say you went 5 units down. You know, well, you went 2 units back, so it'd be -2. And then you go 5 units down, which would be -5. So then it ends up still being the same 5/2. Okay? So no matter which way you work it out, it's going to give you the same value.
So would it be written as y equals 5/2x plus 3?
It would be... That would be, well, no, that wouldn't be the slope. The slope is just m, come on, equals 5/2. The slope-intercept form for this equation would be y equals 5/2x plus 3, but that's not what we're looking for. We're just looking for the slope. We're just looking for this guy. But that's what it would be up there if that's what you're looking for. Because you know it's at +3 when it's equal to 0, so that's your b-intercept, and then you know the slope from there. All right, we're sitting at question 20. We are halfway through this, and we're only an hour in. Do you guys want to take like a 15-minute or something? I can pause it. Okay. Well, I don't want to like get people tired. Oh, there's 3 more on the page? I didn't know about that. My bad. Let's just do 3 more of those, and then we'll, you know, take a pause. Write the equation of the line. Be sure to correct variable. Okay, so in this situation, we're not seeing any change in the line, which means that one of them is going to be equal to 1 variable, right? So in this case, we know that no matter what the x value is, y is equal to -6, right? So we're just going to say y equals -6. Now, on the other hand, if it was, draw a different line here. No, I went to do something different. I like that one. If I did this line here would be that no matter what my y value is up and down, my x is going to be equal to positive 6. So that would be x equals positive 6. And the way that you know which variable it is whichever line it crosses through. Because see how this one crosses through the x line right here? That tells me that I'm using that x variable to denounce it. If it's crossing through the y variable, like it is here, I'm using the y variable to say y equals that, okay? What? Right, because it's one flat line. Because no matter where my x value is, no matter what it is, my y is always going to be the same number. X could be 0, x could be infinity, x could be -2. It's always going to be 6. So that's how we look at it that way. I'm just letting you know that when you're looking at these, whichever origin line it runs through is going to be the variable you're going to say it's equal to. It's a little shortcut so you don't remember. Because if this one crosses the y-axis, you're going to say y equals that number. If it crosses to the x-axis, you're going to say x is equal to that number. Okay? We good? That's it. That's the equation for this line is just that y equals -6. Because we don't have any angle on it, we don't have any, we have the intercept because the intercept is just that at all times. So it's just a number. It's just saying no matter what the other, whatever the other variable says, this one is always going to be that, no matter what.
Green, red.
Oh, I would love to do Christmas colors, but I've been told I have to, do nice stuff. All right, so determine the slope of a line represented by the equation this. All right, so remember what I said next time we see these? We're trying to make it into an intercept form, right? So this is y equals mx plus b because m is our slope. So we're going to do reverse PEMDAS, right? Reverse PEMDAS. We're going to do our addition and subtraction first, and then our multiplication and division. So addition and subtraction. What can I add or subtract away from the 8y? Okay, subtract away a 2x, right? So we'll end up being 8y equals 2x plus 7. I personally put my x value in front of my numbers so that it still looks the same way as the formula. Some people will, what? Because it was positive on the other side, so when we subtracted 2x from both sides to cancel out the 2x over here, we ended up with -2x over there.
So maybe someone by subtracting the 2x and then do it on the other side underneath it. Hey! So,
we're going to subtract 2x from both sides, and that's where this one cancels out, and then we'll end up with 7 minus 2x, so we'll have minus 2x plus 7 there, okay? At that point, I then look at this and go, since I've done my addition subtraction, I'm going to do my multiplication division. I want to get y alone, so I'm going to divide it by 8. And that means I'm going to divide this entire part of the equation by 8. Yes, I'm talking specifically to you, sir. So then we're going to get y equals, and this is when you break it up, -2 over 8x plus 7 over 8. I can simplify this, right? Going to simplify this to -1/4. And if I'm looking at my variables here, y equals mx plus b. The one that I'm looking for is right next to the x here. So, no. This here is my slope, right? So my slope is going to be -1/4. Right. And our m is tied right to our x. So we'll say that m equals -1/4. And that is our answer. Because m equals slope. Just write that up there. M. All right. So we got one more on this page, right? Okay, so this is fun. We just get to plug in points, right? Now, if I want to do this really quickly, I'm going to look at the center value with the 0 there. So when x is 0, y equals -2, right? The first one, does that work out? Yep. Hey, come on. That one works. The second one does not work out. Third one does work. Fourth does not work. All right, so then at this point, I'll look at any other number on the system. I like the whole numbers. I don't like doing the half numbers because it's hard to sometimes see on the graphs. So I'm going to go with the -2, -1. So when x is -2, so go over to -2, y is -1. That works for that first one. Oh, come on. Let's look for the other one. Uh-oh, that's a wrong. So that's not right. This one missed here. This one missed here. But this one here has that one. That one has that one. So our first one will be our correct answer. Okay? I personally say always start with the one that's equal to 0 because it's the easiest one to find, and it'll usually get rid of half of your equations right off the bat. It's kind of a process of elimination by sticking in the numbers and seeing if they match the line still. All right, so at this point, I'm going to pause this recording, hopefully, maybe. I hit that button. And let's go on to question 24. It's going to get sunny real quick, isn't it? Yeah. All right. As much as I want to, hold on. Hello. There we go. Yeah, give me one moment on that. I'm going to end up going out of the Bluetooth range. Do I have any other tutors around? No. Okay. Oh well. Give me one moment. There you go. It's still going to end up, blinding us, but at least it'll take a while. Okay, so graph the equation. I don't seem to have a graph here. Cool. I'm going to make one real quick. Insert. No insert shapes? Really? Okay. I didn't expect that. Let's, Yep, I like purple. Well, let's just make this as simple and crude as we can because the professor didn't give me a box. I'm going to just do this to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So wait, what am I doing? What am I doing? This is ridiculous. I feel bad for the people on the online review because they're going, why is he taking so long for this? Let's see, so 3, 6, 10. Going 2, that'll be there, and then 1, 2, 3, 5, 9, 10. Okay, so it's a 10 by 10 square. I like that. And then we're just going to make a line real quick. Really? Where did my perfect lines go? That cool. Like, oh, you don't need to draw another straight line. See? There we go. Okay, so it's on a grid. I can draw again. There's a different color right now for this because I just did that all in that color. I like orange. All right, so graph the equation y equals 7 over 3x plus 1. The way I did this is so that it's going to be This is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. Okay, good. Yeah, but again, I just need more than 5 notches because of the 7 over 3. Beyond that, it'll work out. It'll work out. So, because we know that when y equals mx plus b, when x is equal to 0, then y equals b, right? So we'll know that y will equal 1 when x equals 0. So going to the y and x line, we're going to say at x being 0, our y is going to be 1. So that's going to be one point that we have for sure, okay? The point that we know for a fact is going to be 0, 1. We could, there you go. So we'll just 1, 2, 3 over, and then we'll go up 7. So 1, 2, 3, 4, 5, 6, 7. And then from there, if we drew a line there, that would be our line. And proof of concept, since we went over 3, so that would be 3 positive, and then 7 plus 1 becomes 8. That would be your secondary point, and you could figure that out by solving back for the slope and seeing this is the right slope, okay? But we did it by finding this, and oh, where did I put my, it's there, right? Yep, there. That was my other point. I can always go back and say I can go 7 down and negative 3 over, and it'll be right there. So, all right? Because when I insert x is 0 on the y-axis, the y will equal b, and that's how I know that then y ends up equaling 1 when x equals 0. Because I just end up taking out the m and the x, and what's left over is the intercept, and that's where I start, because that gives me 1 point, and then I just tell it that I'm going to rise 7 and run 3. Oh, come on. What did I lose over there? 3. Okay. Thank you. Somebody was paying attention. That's good. All right. So that's how you would graph the equation without having a graph already written for you. Hopefully you guys will, and it'll look better. Do you guys have one on the paper? No. Okay. Side note for the future, make sure students have graph when required to graph. Apologize on that. So 25. All right, so 25, we're going to simplify this. So the first thing that we need to know about equations that have a bunch of different exponents. Exponents is kind of like saying it's a language. Only the things with the same exponents can talk to each other. So everything that's to the 4th power can add or subtract from itself. But something that's the 4th power and something that's the 3rd power cannot add or subtract away from each other. They don't have the same amount of x's, so we just ignore that, okay? So first thing we're going to do is put everything that's got the same variable or the same exponent strength together, and then we'll simplify them down from there. And we're looking up here, and I see 4 seems to be my biggest one, right? So I've got a 2x to the 4th. I'm going to make my lines a little bit neater. 2x to the 4th. And then I've got another one here, so it would be minus 7x to the 4th. So I know those two are going to go together, right? And then I've got, so there's 2 to the 3rd, so it'll be plus, and you can always put a plus in the center here, and then make sure you put the signs in front of each part of it, and no matter what that ends up on the inside, if it ended up a negative number, you just go, oh, minus instead, okay? But here we'll have a 3x to the 3rd plus 6x, and that's where I'm like taking the sign in front of it and adding it to it, so 6x to the 3rd. Then the next one down is going to be, do I have a 2? I do not have a squared, but I have a regular 10, so it'll be plus 10x, and there's no other x variable there, or regular x there, and then we'll do plus 2 as my regular number. So what you see here is in my parentheses, I have two things that need to be simplified down. We're just going to add them together. 2 minus 7 is going to be minus 5x to the 4th plus 3. What?
When you're adding and subtracting,
The 4, the X4.
X to the 4th.
yeah, so it's not affected when the bases are the same. You're adding and subtracting.
Well, what do you mean the basis?
When the bases are the same,
Yeah.
the exponents are affected.
No, because that's the language. Remember, we're looking at the language right now. So they both speak to the 4th. Because we're not multiplying or dividing or squaring or exponenting, they don't get used. Like, they're just there as placeholders when you're adding and subtracting. So then I go over here and I go 3x cubed plus 6x cubed will be 9x cubed. If they were multiplying, it'd be a different story. Then we'd be adding exponents and then so on and so forth. We'll get to that. Don't worry, we'll get to that, just for you. Plus 10x plus 2. So I've simplified each part of it, and this is something that I know a lot of teachers liked back when I was going through the college, is you put your biggest exponent first and you work it down. It's kind of like a power scale. So this is your strongest thing, and then you go weaker, weaker, weaker. So it's organized. All of them have been simplified. This is the best we can do with this one. We're not factoring it. We're not doing anything else right now. That's it. Just wanted to make it a little simpler. Number 26, and I can barely see that part of my screen. Great. Let's draw it there. Hey, we're making pretty good time. Simplify. Okay, so now that we're doing multiplication division on the exponents, how do I put this? So we'll have the right. So we're gonna have x to the 4th here, y to the 5th, right? And then x to the 3rd, y squared. So another way of looking at this is, and we're just gonna put these off to the side for right now. We're gonna deal with the variables in a moment because it's a fraction. But now here comes the sun. All right. We're going to do, it was basically by saying x 4th power divided by 3 and y to the 5th power divided by 2. Right. Well, yes, at that point we're subtracting exponents because we have, for example, if I wanted to move, and I should do this, move all the x's to one side of the, stop it. When I move it to one side of the division line, I'm subtracting away from that. So, for example, I have positive 3x down here, right? So if I moved it up here, it would be x to the negative 3rd, okay? So if I did that and moved that up there, x to the 4th times x to the negative 3rd would just be adding and subtracting of exponents. We'd end up with just an x on top, right? Yep, that's how we're going to do it. So we'll do the same thing with the y, negative 2. Because whenever you move a variable across the numerator-denominator line, you flip the exponent. So if you have y to the y squared down there, it'll end up being negative squared at the top. But the negative sign goes on the exponent, okay? So if I have y to the 22nd down here and I move it up to the top, it'll be y to the negative 22nd. And then I add the exponents together. 5 minus 2 gives me y to the 3rd. And the other part about this is we're looking at a fraction here. We've got 12 over 2. We can simplify that down to 6 over 1, right? And because this is still 1 down here, everything else left down here was a 1, so we can ignore that and we'll put 6 up here. Which just means that we can say this simplified would be 6x and y to the 3rd. Okay? Don't even have to worry about the under part of the fraction anymore. All right? Now, if on the other hand you have a negative exponent in the top, you can move it to the bottom and add it down there. So if I had like a z to the negative 15 up here, I can just move it down here to the bottom and make it z to the positive 15, because we really want positive exponents rather than negatives. We just use them to cancel out when we're moving them across the equal sign, okay, or the division line. So we're going to go to the next one real quick. I can't even see what I'm writing here. 27, right? Okay. All right, so simplify. This is going to be, so whenever we're multiplying two exponents together, or two variables together that have exponents, we add them. But when we do an exponent to another exponent, we're just multiplying the exponents together. So it'll be like me saying, I'm going to take this 4, I'm going to multiply it by the 3, I'm going to multiply it by the 8. Okay? So we'll do the number part in a minute. Just know there's a 3 over here to the 4th power. Now the next part is going to be x to the 3rd times 4, and then we're going to do y to the 8th times 4. Okay? So at this point, 3 times 4 is 12, so then we get x to the 12th, and we get y, 8 times 4 is 24. What?
Oh wait, because it doesn't have this.
Here, we're powering, no, we're putting it to the power, we're not multiplying it. We're powering that equation. When you do exponents on exponents, you multiply and divide them. When you're doing exponents that are the same variable multiplied together, it's adding, subtracting. When there's adding, subtracting, you don't even deal with the exponents. So it's like one level higher to everything. Do we get what I'm saying? What? 8 times 4 is 32. My bad. I'm dealing with a lot of light here, and I'm very distracted by the light. I'm terrible with light. Shiny things, terrible. 32. 32, right? And we have cookies. We have cookies. Of course, the dark side always has cookies. You never heard that one? All right, so looking at this now, if we said 3 to the 4th, I could say automatically that's 81. Because I'll look at it and go 3 times 3 times 3 times 3. I say this is going to be a 9 times 3 is 27 times 3 will be 81. Or I could just go 3 times 3 is 9, 3 times 3 is 9, 9 and 9 is 81. That's how I knew so quickly, because it's a perfect square of another. So whenever you see something to the 4th power, just think about it, figure out whatever it squares to, and then just square those again, and then you won't have to do all of this shenanigans down here.
So it's x cubed. So it's x cubed, and that 3 is the 4th power, or is it?
Well, because we multiplied everybody by the 4th power, 3 is to the power of 1 right now. There's an imaginary 1 up there.
No, I'm talking about the x cubed.
The x cubed? Yeah. Yeah. X is 12.
And then
Like,
8 times 4.
sorry, I'm moving this so they can see it because of the light for our screen. But
Yeah. All right, yeah.
so then we know what our coefficient is 81, right? So we're going to write 81. And we know that our x value is to the 12th power. And we know that our y value is to the 32nd power. And that is our answer. Ta-da! Adam, is that part there? Oh. Could you please press the button, Adam? It's going to get really dark, though.
Okay.
What's the next number, by the way? 28? I'm going to guess that's a 28 there. Is that a 28? Hey! Good to guess. Alrighty. Well, congratulations. We're now in total darkness. Now we can see our screen. What? 5 plus 28 is 40? Please tell me where you're getting this math, sir.
I thought that there's only 5 more problems, but we actually have 4.
We're doing. It's crashed a few times, and I did a pause in the middle of it, so hopefully it works on the recording later. But he
Yeah, no,
red button say record. Okay. All right. So in this case, we're still doing the same multiplication, and we're just going to multiply this one out to everybody, right? So it'll be 12 to the negative 4th. We're going to let that just stay as it is. We got 3. Do we cancel that together, or do we try to remember that part? But right now we're just going to deal with the z. I really need to. Come on. Z to the 8 times negative 4, and then z to the 3 times negative 4. And, okay, so, right. So at this point, we're going to do the exponents up here. So 8 times 4 is going to be 32 this time, right? I'm not crazy. 32. 30. Oh, that's way too big for an exponent. Come on. Z. Well, we just did this multiplication here, so we're going to take it over here. It's going to be negative 32. And then same thing for the bottom z over here. Z times 3 to the 4th is going to be negative 12. So these are both negative numbers. But if I move the heavier negative number to the other side of it, it'll make them positive, right? So what we're going to do is we're going to get rid of this by doing a positive 32 here. We're going to get it z positive 32. So these will cancel out. I'll have a 1 on top. And then since we're multiplying these, we're going to subtract exponents. So 32 minus 12 will be 20, right? Or 20. Yep. So z to the 20th. Okay? Now we got to deal with the coefficients. So we already know that negative 4th, so we're going to, because they're both negative exponents, we're going to do an early game of switch. So this one's going to be 3 to the 4th power and 12 to the 4th power. The reason I can do this is because when I flipped them over the division line, I was able to make both of their exponents positive.
So you flipped it
Right.
to make it
Right. I flipped it on purpose to make the exponents positive because negative exponents basically just mean that it's a positive exponent on the other side of the division line. That's the best way to describe it. Yep. So when I flip it like this, I'll end up with 3 to the 4th power, which we already know is 81. And then if anybody knows 144 times 144, please shout it out now, because that would be 12 to the 4th power. Calculator people, please. I do not want to do this one. I'm sorry. $20,736. See, if I had actually gone over my stuff, I would have looked really impressive knowing that. Okay, so that is our math. Can we divide 80 by that number by chance? Let me get a graphing calculator because 81 divided by that. Hey, you'd be surprised. 736.
I don't think that they would write this question out if it was.
Yeah, it is. It is a perfect number. So technically, I could long division it. Yeah, there is a long division way of doing the 81 and then just adding zeros as you go to get this in there to where you're 81,000 and you're 20.
Don't you love when you're doing finals and like you do a question like this and everyone else is getting up and walking out?
Yeah.
kids just feel like, man, do I risk staying last in class or do I just go ahead?
Because you end up with 0.00, periods there, 0.003. But again, for the people who are on the review or on the video, I'm sure you have time to long division it. We don't. This is a 4-hour review. I'm trying to get it done as fast as possible. So we're going to just say that it's 1 over 256. Thank you. And since it's times the 1 over the z to the 20th, you end up with 1 over 256 z to the 20th as your answer. I have no clue how that relates to the real world, but that's your answer.
That'll work.
What? Yeah, but the better part is like when you're watching the video back, you actually see how I get to each part, so you'll see it in order. So it won't look as crazy as like a screenshot at the end, because we started doing that the first semester. We did screenshots when I was done, and it just got a little out of hand. So next question is 29. 29, simplify. So remember the whole thing about keeping things with like powers together? All I know for the fact is we're doing subtraction here. So I'm just going to make everything on this side negative to what its original original sign is, okay? So since it's a positive 4, it'll be a minus 4x squared minus 5x minus, so it's plus 5x minus 3, so then plus 3, okay? So I just flip them automatically, so now I'm just adding them together, all right? And I'll just bring down the other part, 6x to the 4th minus 2x plus 1, and now I'm going to start grouping them together. So I have something to the power of the 4th, but I have nothing else to the power of the 4th, right? It's only 1, so 6x to the 4th. That part's done. Next highest exponent, there's no cubed, so we're going to go to squared. So minus 4x squared, because there's only that for squared. And the next one we're going to have plus 5x minus 2x. And then after that, we get the 1 and the 3, so 1 plus 3. So I'm just going to have to simplify these. 5x minus 2x is 3x, and then 1 plus 3 is 4. 4x squared, 6x. Just took out that entire line. Fine. Fine, I'll do it this way. I'll write it the proper way rather than backwards. I'm starting to realize whenever I'm writing this way, it cancels stuff out. When I write stuff this way, it doesn't. I have a habit of writing backwards. So,
20,000 years ago, was putting it backwards.
Yeah, I'm just getting punished for it, though. So that's your simplified answer. We're not factoring it. We're not doing anything else fancy with it, but we've simplified it, okay? Yeah. Anyone who's sitting here right now should be copying this down. Everyone else that's online should be probably playing it back over if they're still confused. Your final? I wouldn't do that. That's a tech device. You wouldn't want your teacher to have to take those away from you. They wouldn't give them back. All right, so question number 30. Please just scroll down. Thank you. All right. Nope. Question 30. Simplify. So, getting back to drawing. So 3x minus 4. 3x minus 4. Simplest way to do this. Since it's squared, we're just going to FOIL it out, in fact. So FOIL, first time first. 3 times 3 is 9, so 9x squared, right? That's our first variable. And I'm going to go outside, so that would be 3x times negative 4 will be minus 12x, right? I'm going to run out of colors real quick. Give me more creative colors. Then we'll do the FOIL, so in, so it'll be this one and that one. So it'll be 3x times negative 4, so negative 12x. And then you get last, which will be this and that one. So that will be positive 16. Then we get to do the fun part where we take the two and put them together, because this one and this one are the same. Yes, I'm getting more colorful as I go, by the way. Okay, please, yes. Right, combining like terms here, minus 12 minus 12 makes minus 24x plus 16, and then you get the 9x squared up. 9x squared. And that would be how we simplify it. All right? Any questions? Yep. Because it's not asking us to find the equal to anything. It's not asking for a point of origin. It's not saying it's equal to y. It just said these two need to be multiplied together. And that's the only thing I can do. Everything else is either a different exponential value, so none of them can work together, and all of the coefficients, two of them are even, one of them is odd. None of them have a number that I can pull out of all three of them. Okay? And since it's not asking me to factor because we just FOILed, so that would be a simplified form at that point. Number 31. What is the greatest common factor of the following expression? What's our guesses for greatest common factors? No, two. So you're right. I like 2 is a very good number, but oh, now we're looking at that. Okay, because everybody has at least 3 z's, right? We can take 3 z's away from everybody, and that would work. So we know that z to the third is definitely going to be taken away from this whole thing. And then, and how we know that is because we got 1 to the 5th, to the 4th, to the 3rd. The 1 to the 3rd is going to be the one we're going to have to take everything away from. So and that's how we automatically know. If there's a z to the squared, we'd only be able to take away z to the squared. So the smallest variable exponent is how many of them you can pull out. At that point, somebody said 2. I like that. We're going to start with 2 and see where that leads us. So 8z to the 5th divided by 2z to the 3rd. We're going to take away 3 of that, 3 of the 5, right? So we'll have z squared, and then 8 minus 2. Right? Yep. So 2, 8, so that's going to be 4. So 4z squared is going to be the first one. And then we're going to do it by the second one here. So 2, 10, so that'll be 5. And we'll say z because 4z minus 3z is 1z. And then we're going to take away all the z's on the last one, and we're going to do 16 divided by 2, which is 8. So the greatest common factor, the GCF, equals 2z to the 3rd. If I then looked back at this and saw they were all even, or there was some number like 3 or 5 that they were easily all divisible by, I would then go back and add that to this number out here. So if I said, for example, oh, they're all divisible by 5, I would then multiply the 5 and the 2, and it would be 10z to the 3rd out there. But that's how you would slowly make sure you have the greatest common factor, is go for the smallest numbers first. I can take out a 2, I can take out a 3, I can take out a 5, and then just multiply them out on the outside. Okay?
So you were putting like down the lowest one? Oh, no,
the outer part. Because that's what I was able to pull away from everyone. It's the greatest common factor of all of them. All of them share that factor. you're putting the whole thing in and you're not just putting in the greatest common factor. I gotta say this right because I'm on the speaker. It is RTQ. Read the question. Always read the question. ARTQ. If you don't read the question, no matter what answer you put in there, it probably will be wrong. So factor by grouping. Factor by grouping is useful when we have 4 different variables, and it is about a 3-step process. So, what? 4 terms, yep. So when we have 4 terms, I'm going to start this by doing this a little bit larger. So we've got x and y plus 5y minus 4x minus 20. So at this point, the first thing I'm going to do is say that, say that again, here to there. And make sure that this second parenthesis gets that sign. If it's negative or positive, always make sure it gets that sign. So now I've broken it into 2 different parts. I've grouped it, right? So in this first group, what is my greatest common factor? What is something I can pull off of both of them? I can pull a y off of both of them. I like that. Okay, so down here in step number 1, we're going to say y. We're going to say xy divided by y would be x. And then we'll do 5y divided by y, which would be just 5. So I've made this little inside part here. This guy is important because now we're going to take him and we're going to say, well, how can I make that become him? So if I was dividing this by that, what would I divide it by to do that? Because I'm basically trying to make another x plus 5, right? So I see that, yep, there's a negative 4 here, that if I took it out, that would make this x, and more importantly, it would make the negative 20 a positive 5. So that tells me that this piece here is going to be, I need new colors. I need a new color palette. I already did pink earlier. So minus 4 is going to be there. So we're going to take the y, and minus 4, they're going to be together. Now, we've got these x plus 5s in both parts here, but we're just going to say, because we got both parts of it, it's one equation part over here, so we'll just do x plus 5 there. Then we'll take the other parts, being the y and the minus 4, and we're going to just drag them down there and make them times y minus 4, and voila. We have factored it by grouping. Is it a little more organized and colorful for you?
I love the spring blue. Sky blue.
Yeah, the highlighter. That's because I was trying to say those parts together. So, okay, so we took it, we split it into 2 different parts, right? And then we said, for the first part, what is my greatest common factor? And we said it was y. Y is the commonality between them. So we're just going to pull a y out and give us this inside piece. This inside piece, we want to get the same inside piece over here. That way we can say together they grouped into one item. So when we do that, we're looking at the second part and say, how can I get x plus 5 out of that part? And the first thing I notice is I can pull a negative 4 out of it. So when I pull the negative 4 out of it, you get the x plus 5. I'm going to say, because these are both x plus 5s, we know that one part of it's x plus 5. Then we took all the scraps on the outside, and we pasted them together, and that's the other one. So that's why we got the y and the minus 4, and we stuck them together down here, and they become y minus 4 times the x plus 5. And if we did our foiling, we could prove this, because x times y would be x, y, the x times negative 4, negative 4x, 5 times y, 5y, 5 times negative 4, negative 20. So it would factor out the same way. All right? Factoring by grouping is an oddly specific item, so it won't be used too much. You might see it in one question on your final, but It's not a key core concept. So 33, what am I looking at? Factor. All right, so what method are we guys more familiar with? The slide and divide, factor by grouping. What's our best method here? AC method? AC method. Okay, so first thing I notice is everybody has a common even number, so they're all divisible by 2, right? So I'm just going to make this a little simpler. Rather than dealing with big numbers, we're going to pull out 2 from everybody. And I should probably put my numbers down to there again. So if we're going to divide all by 2, we're going to end up with a x squared minus 6x plus 9. And there's, of course, you know, the parentheses, and there's a 2 out there. So that's just sitting out there. Now we can factor these parts here on the inside. And because I only have a 1 now in front of my x squared, this is just the teaching I know. You put x's in the front of both parts there. Now, for the signs, there's a way to bring the signs down and not really have to worry about it. I'm going to do it in a different color because I'm going to just directly bring down this first sign, okay? So, negative brought it down. Then when I do this one, I'm going to say negative times a positive, because that's a positive there, right, would equal a negative number, correct? So that means this one will be negative as well. At this point, all I have to remember is when I get my 2 numbers, my 2 factors, the greater factor has to be in this first one because it pushes everything negative. When there's adding and subtracting of the values, you want whichever sign is expressed to be the bigger factor. Best way for me to explain it right now. I'm going to go back to the regular colors. Really. So at this point, AC method, you multiply A, which is going to be 1, times C, which is 9. Because you remember this is A, B, C here for our variables. So 1 times 9 is still 9. And we're looking for something that will subtract up to negative 6, but multiply to 9. So the factors of 9 that we can think of are 1 and 9, and 3 and 3, right? So if both of them are subtracting, minus 3 would equal minus 6. So we know that this is our factor pair. Put a 3 there, put a 3 there. So because these are both identical, I can write it as x minus 3 squared. Because they're both the same one, I can just condense them into 1. And I got to remember to bring the 2 in front of it. So 2 times x minus 3 squared would be the factored form of this solution. Yep.
I got I can do the first step.
Okay.
I got 2x minus 6, 1.
Yep. Right, but 2x minus 6, can I pull a common factor out of it? I can pull out the 2, and then it would end up, because say I did the 2x minus 6, I'm doing it visually for everyone who's not here, and then it was x minus 3, which you can work into this equation. Your brain will then say, oh, I can just divide this one by 2, giving me a 2 on the outside, x minus 3, x minus 3. And then you just end up putting this as x minus 3 squared because we like shortcuts. We like things to, mathematicians like, avoiding writing if at all possible. They don't like writing. They like skipping steps. That's what mathematicians do. So this would still be our answer at the end, even if we went that way instead. Okay? All right. Number... We're going to keep focused on this right now. So this, I'm trying to remember the term for this, perfect square. Thank you. I've been doing a lot of math today. So a perfect square is where the center exponent is canceled out. So technically, even though you see 49w squared minus 81, what you're actually seeing is 49w squared plus 0w minus 81. The simple way of this is we know that these are both perfect squares, so you would just end up saying it's 7w minus, see, what is it, 9, and then 7w plus 9, but I'm going to show you how it works out over here in the factoring of it. So if we still did the same method here, put the plus sign down, plus times a minus is a minus. That's how you get your two sign changes. And you can multiply these together and then figure out what adds or subtracts to 0, but it's just going to be the same variable, so that's where you go. This is a 7w, this is a 7w, and this would be a 9, and this would be a 9. Because when you multiply 7w times positive 9, you end up with 7 times 9 is 63. 63w, and then you do 7w times negative 9 makes minus 63w minus 81, and that would be 40, come on, don't give me that, w squared plus, and then you end up simplifying these two together to be 0w, and that's how you ended up with that in the first place, okay? So just factoring them out will end up giving you, and I can't put them together because one's positive and one's negative. You'll always know that when you see a perfect square like that, you'll always know that it's the same numbers, so they're the square roots of it. One's positive, one's negative. All right, we good with this one? It's starting to hurt. All right, need more water. Next one, 35. Solved by factoring. So this is the same as the ones before. Don't be afraid of the fact that there's a equals 0 there. It just basically at the end what it's saying with the equals 0 is when we get to our factors being this and that, and they end up equaling, equaling 0. It just means that each one of the parentheses themselves equals 0. And since there's the variable m in there, eventually we'll get to an m equals this number and this number. Okay? We'll eventually get down to that part. And I put that in the worst place possible. So, no. Sorry. Just moving this all the way over there. But that's how it's going to end up looking at the end. So, doing our factoring, we've got m squared plus 13m plus 42. And we're going to do the AC method, because I like the AC method. M squared is just 1, so 1 times 42. So I need to figure out what multiplies to 42. So multiples of 42 that add up to 13. You just automatically found the answers. Okay, so we both know they get m's in the front because there's no coefficient to the m's. Bring down the positive sign. Positive times a positive is a positive. Put a plus there. So we're looking for numbers that add together for a fact. And then you go through the list of 1 and 42, 2 and 21. Is there a 3 and something? 3 and 14? 3 and 14. And we eventually get to 6 and 7. I don't think there's a 5. I don't think there's a 4. Yeah, no, none of those. So, and then you realize because it goes 6 and 7, it becomes 7 and 6, and you've just flipped it, and you'll end up getting the rest of these just reversed. So.
Or you do 14, negative 3 and positive 14.
How?
Because, oh yeah, sure.
Either way, 14 minus 3 will end up being 11.
Yeah.
We got 13. So we notice that if we're adding them all together, because both are positive. Hey, give me back that plus. All right. Equals 20, or no, 43 equals 23 equals 3 and 4 is 7 equals 17 equals 13. We have a winner. 7 in front and 6 in the second. But that's just a quick way to find it, because we know it's both positive, we just add them. So if we know this is factored here, remember we're going to go back and plug it in over here. M plus 7, M plus 6 equals 0. So that means that, and I'm going to do it in a different color because this is the second part of the step you really want to look at. I didn't write a 3. I wrote an M sideways. Okay, cool. M plus 7 equals 0. Okay, good. M plus 6 equals 0. In this case, we'll then subtract 7 from both sides, canceling that out. So M equals negative 7. Same thing with the 6. Minus 6, minus 6. So that means M equals negative 6. So then we'll say M equals negative 7 or negative 6. And when you're looking at the shape of this, when you have like a U for your on your graph, you'll see that the 2 points where it meets the X line is going to be negative 7 and negative 6. So it's going to look more like, hold on. It's going to look more like, fine, it's going to be there and there. You're definitely going to see that's going to be X equals negative 7 and that's going to be X equals negative 6 on the graph. That's what it would look like if you graphed it with a graphing calculator, but that's next class for you guys. But remember, every time you see at the your question, when it says solve by factoring equals 0, that means you are looking for what M will equal at the end of it. So M will equal negative 7, negative 6, okay? Only when we see that 0 do we have to go that far. If it just says factor, factor just means you split it, and you split it, you're done. Come on, go away. Go away. Solve by factoring. Do I see any common? Oh, I did not see common numbers. That's not fun. Okay. For a second, I was going to say we could divide it all by 5, but we can't because we have a 21 there. 36. Yeah. Well, I mean, it's
Q&A at the end.
right. I've just given them a decent amount of time of Q&A. Do I cut the recording when I'm done with the running through them, or do I allow the Q&A?
Q&A there too, unless it goes off topic, like how is my grade determined or something like that. If it's not related, just
Do I just like add new sheets at the end and just start drawing them?
yeah.
No? Okay. What?
The recorded part, like it's the Q&A is in the notes. It's just in the recorded part.
Okay.
We'll cut it.
What do you guys think? Are you going to want your Q&A session to be like recorded so you can remember it later? We'll find out at the end of the video, I guess. All right, so solve by factoring. So this is where I have to actually use the A and C method seriously because I cannot get rid of the 5 as much as I want to. So 5 times 20 is going to be negative 100 and negative 20. Wait, did I do that wrong? I did that right? Okay. Anyways, we're going to just make these parentheses here, right? I'm going to say that they both definitely have an x there because there's an x squared. So definitely there's an x on each side. One of them's going to get a 5, one of them's going to get a 1 because, you know, this is a prime number. Don't do it. I'm going to put that back there. Don't do it. So we know those are going to definitely be those variables, but there could be several other variables here that are going to get us added up to 21. So bring down our positive sign plus, positive times a negative is a negative, so that means it's going to be one number minus another number is going to equal 21.
So how would you be able to just do that? Because this is not an equation with a leading coefficient of 1. So how are you able to just plug it in to say...
Plug which part? Those things there?
Yeah, because I know you're going to do it.
What I'm doing is I might get it wrong the first time, but it's trial and error. I'm only going to have to do it 2 or 3 times. And that's just factoring it at the, or boiling it at the end just to prove whether or not I can do it. Okay? So going back to this part, we're trying to get negative 100 to 21. If anybody would like to help me on this headache, by all means, 1 times 100. You get 2 times 50. That's not even going to work. 3 times does not work. 4 times 25. Oh, there we go. That looks good. I like that. What? Yeah. Well, since I'm going for a positive 21, that gives me this would be the positive number and this would be the negative number, right? So if I'm doing that, then I got to go back. How do I pull this back out again? So I know there's going to be a 5 and a 1, and the other part of that is going to be 5 and a 4? No. Yeah, 5 and a 4. Because 5 times 4 is 20, and then 5 times 1 is 5. So I know that the 2 factors I'm looking for the 20 is going to be a 5 and a 4, right? And so I know I got a positive 25. That means the 5 is going to be positive, right? And that means the 5 has to go on the other side because 5 times 5 is 25. So that's where I got those there. That means this is going to be the 1, and then this one's going to be the 4. Testing that will go that times that, 5x squared. Then times that would be minus 4x plus 25x minus 20. Do the math. Plus 21x. We know this is going to be the right one, okay? But that's where it could have been the other way around, depending on how the variables turn out. So once you know for a fact, because usually your first exponent or your first coefficient will be a prime number, so it'll be 1 in itself will be the only way to get to it. But the other one, you just have to figure out which way fits the number. So if I had put the 5 times a 4 instead and made 20, 20 minus 5 would have given me 15, and I would have known that wasn't the right one. So I would have just gone back and flipped my variables in these 4 slots until they work, okay? That means there's only 4 possible chances. So I've got a 1 in 4 shot getting it right the first time. And the more you do these, the faster you're going to see it. Kind of like with long division. The more you do long division, the faster you're able to do long divisions. So always look for spare practice in factoring if you can. It's a pretty simple thing to pick up. So am I done? I've got x plus 5 times 5x minus 4. Am I done? It's quiet here. No, I'm not done. I'm not done, right? Because remember, it says equals 0 up there at the end. So now we've got to figure out the solution for each one. So if I'm going to switch it up, colors to blue. If it is x plus 5 equals 0 and 5x minus 4 equals 0, I'll then just subtract 5 from both sides here. Cancels that out. X equals minus 5. Behave. There we go. And then we're going to subtract or plus 4 to both sides. Cancel. So 5x equals 4. And then we're going to divide both sides by 5. Because remember, reverse PEMDAS. And that's going to give us x equals 4 over 5, because those canceled. X equals 4 over 5, and x equals negative 5, and we'll write that as x equals negative 5, comma, 4 over 5, making sure to put the lower value first if you're on homework stuff. Which hopefully we're done with all of our homework. And that would be our answer at the end.
36?
What? I believe this is still 36. Is this 36? Yep. Right, because it was equal to 0 up here, so we have to go back and find that. For which one? 35?
Did we find out what x was equal to for number 35?
I believe we did.
Okay, so.
Yeah, it's right there. 7 and 6, remember? Well, negative 7, negative 6, because of the way it flipped around. But we got that one. So 37? Ooh. Okay, so for this one, everyone understands how cross multiplication works. So we'll just end up cross multiplying. But the thing is, we got to figure out which is the right way to set this up first. So reading this question, in Tacoma, the tax on the property assessed is at, so a tax on the property assessed at this much. So that means the property value, we're going to say is this line, and then the tax is this line, okay? So it says the property asset, so the property's value was 480,000, right? And then we're going to say that its tax for that one, right? For that exact value, for that property, was 10,560, right? And it says if the tax rates are proportional, if they are, equal sign, how much will the tax be on a property assessed at that? So property assessed at was the top side, right? So we'll just keep that the same, 830,000. We want to know how much the tax of that one would be, so we don't know it, so that's our variable. Now let me look over here and see if that matches what I made at all. So let's see. This one, the x is over the 10, so that wouldn't work, right? So he doesn't work because that's on the wrong spot. Next one, we got the 48 in one side and the 10 underneath it, so that's good. Then we've got the x on top and the third and the 83 on the bottom. But the problem is this is the property value here. This is tax. This is property value. This is tax. These two aren't in the right alignment, so they don't work right. So I keep going down. That one's got the 10, right? So this is both tax. This is tax. This is property. This is property. And if we look at the lines, we know these two were connected, and these two are the ones with the variable. So this is going to be our right answer. And we can check the last one and see that this is the variable with the one that we know is assessed. So these are both tax. These are both property. However, this property was supposed to be with that tax, so we know that is also wrong. Okay? So I wrote it upside down, but that's interchangeable because when we do cross multiplication in the end, it won't be. Just a hypothetical because I don't know how hard they're going to be on your test. How would I now go about finding that actual x value? Cross multiplying, so it would be 83,000 times 10, 5.
Yeah, 830,000.
Oh, there's one more zero. We good?
Mm-hmm.
Okay. Well, 48. No, 100,000. 100,000. Don't scare me like that. All right, and if we wanted to do this, I'm just going to do it on a calculator real quick because, right? I mean, you could eliminate all the zeros first, and then you would be able to figure that out. 10, 5, 6, 0. So just for the people going along, it's going to be 87, 6, 4, 8, 1, 2, 3, 4, 5, comma, big number, 48,000 x. So then we know we're going to divide both sides by 480,000. And that means that the tax will equal 18,260. That's not bad for a value of, well over $750,000. But hey, this is the main part. Hopefully you won't have to do that part. I mean, that's on the one-time purchase of it, right? So it's not too bad. All right, number 38. 38. In 1 month, Vanessa earned so much at her job and was withheld federal income tax. Suppose she earned $1,200 next month. How much will she? So we got the earned money, right, and the tax, right? We're going to make our line. We're going to say she earned $800 in month 1, and she was taxed $50, right? In month 1. Month 2, that's $1,200, but we don't know how much she was taxed. But we're told they're proportionate, right? There we go. Now we're going to cross multiply. So 50 times 12, 5 times 12 is going to be 60. 50 times 1, 2, 3 equals 800x. 60,000, right? I don't have a single calculator person today? Wow. I mean, usually there's somebody already typing and trying to be like, wow, I know the number before you do. All right, so at this point we're going to divide both of them by 800. So 60 divided by 8. 75? Yeah, makes sense. So, yep, 75 equals x, and you can do that from long division of 8 into 60 and 600. Even though this goes in 7 times, it goes 56 times 4, brings it down to 0, ends up being 5, 40, cancel, then go 1, 2. Oh wait, no, because you already canceled all those out. Never mind. Yep. Never mind. But yeah, 75. Just remember dollars. Okay? $75. Yep. Number 39.
There's that sun again.
Yeah, sun's coming back. Last two. And we can just do reviews. All right, so for simplifying, we're trying to pull as much stuff as we can out of it. We know that this root here, because it has no number, is technically a 2, right? We got 36p. What? Because the root doesn't have a number up there, we know it's a square root rather than a cube root or quad root. Because it has no number on it, it does not, it's just a square root, okay? So then we got j to the 4th. So for things that are exponents, roots and exponents are like multiplication division. So I can say that if it's to the 7th power and I'm square rooting it, I can also write that as 7 divided by 2p. So I can divide, basically, okay? So the best way of doing that is if I divided 7 by 2, I would end up getting 3.5, or it would end up being I have 3 on the outside and 1 on the inside. So that means I had 1, 2, 3, 4, 5, 6, 7 X's. I had 7, or sorry, not X's, but P's. I had 7 P's in there, right? I can pull things out only in multiples of 2, right? So I go, oh, I can pull out 1, I can pull out 2, I can pull out 3, right? So there's my whole number 3 that got out. So I know that I'm going to get P to the third on the outside of the root. Who's stuck inside? 1 P got stuck in there. So J to the fourth. Let's see how we're going to do that one. Being 2. So I've got J, 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 and I go, since it's square, I'm taking them out in groups of 2, and they both get out, so then it would be just J squared on the outside. As for 36, the square root of 36 is 6, so I can just immediately take that number out. But I've got to remember I'm multiplying it times the number that's already there. So 4 times 6 will be 24. I'm going to move this over here so you can kind of see that number up there better, since it's 4p to the third is already out here. And what did we pull out? We pulled out a p to the third, right? We pulled out a j squared, and we pulled out a 6. And j's are getting really sloppy. And then we still have, stuck inside the box, 1p, right? At this point, we're going to have to multiply these, changing colors for the next step. We're then going to go 6 times 4 is going to be 24. P to the third times p to the third, we'll just add them together, right? So it'll be p to the 6, p to the 6, and then j doesn't have. All right, let me just repeat that real quick. I mean, it looked pretty sloppy, so 4. Someone read to me what that 4 was multiplied. It was 6 or 3. P to the 3. P to the 3. 6. P to the 3, and j to the 4th. So we have this part, and then we just bring down square root of what? Was it 2? You're right. Thank you. Because when it came out as j. I'm going to let everyone catch up for a moment and let it decide to be nice again. It just deleted a whole line of work. I still vote that this should be moved to this wall so we don't have light coming in on it. But that one you can actually barrier off that side line. But it would take several $1,000s to move that unit from that wall to that wall. Oops, I'm on recording. P to the 6, j squared, square root p. This is our final answer. It's just what I'm starting to think now. There's somebody like in a different room that's linked into the computer that's just like, nope, he doesn't need that answer. 24p to the 6 j squared square root of p. Final answer. Leave it alone, please. Yes? We have simplified that one. I really want to know how that looks like on the video, guys. Like, if I want to know if it's like disappearing and if you guys are watching it just like. So we have the diagonal of a television screen measures 20 inches and the height is 12 inches. So I'm going to go all fancy again and, you know, maybe it won't ruin it if it's, you know, drawn this way. Hey, come. So we know that the height, h, equal 12. We know that the diagonal equals 20. And then we have no clue what the width of it is. So this goes back to the great Pythagorean theorem that a squared plus b squared equals c squared.
Does it matter which one's A, B, or C?
Yes,
This is hypotenuse C, right?
that is correct. Always, always, always c equals I don't know how to spell hypotenuse. Somebody, help me.
Hypotenuse.
Hold on. I don't. Hypoth. Nis? E. There's an E there. Deal with it. C always equals hypotenuse. Okay? What? I don't have Siri, so. So for this part, we don't have B, right? We'll just say that's B. A and B could be switched either one all day long, but the hypotenuse has got to be C. What? Now the other. Why is it C? Because it's a hypotenuse. Hypotenuse is a very, very long one. The longest line in a triangle is the hypotenuse. That's the when you're doing the triangle here and you say this is the right triangle, the hypotenuse is always like against the 90-degree. We'll go with that for now. They're going to change it later in geometry. You're not going to like that part. But for now, that's 3 classes off. We can look at this and we can say, well, we know that A is 12, right? So 12 squared plus B squared equals 20 squared. Or I can, rewrite this as, if I do this up here, B squared equals, because I subtract 2A squared, A squared, subtract A squared, right? So then I end up with B squared equals C. Am I losing pieces over here? Did I just lose something? Just saw that flinch, so minus A squared, right? Because I just subtracted A squared from both sides. That way it becomes B squared equals C squared minus A squared. Because I don't have the, that's where it is. Took away my B. That's what it took away. So at this point, I could rewrite it as 20 squared minus 12 squared equals B squared, right? Everyone got me there? Oh. There's only so much I can do, guys. There's too many of you. Not bad as the last time, but still, a lot of people here. What? Yeah, it's 20. No, we don't know B yet. So we're going to do the math to find out what B is equal to. Okay, so 20 squared is 400, right? And then 12 squared should be 144, last time I checked. And those, oh. Thank you. Where's my delete button? Delete. Hello? Equals 200 and what? 56. 16, I think. The square root is 16, because we got to then square everything, so we can take that back down, because it's b squared, right? 16, okay. Knowing your perfect squares is pretty good. Definitely know them up to 12. If you can know them up to 20, you shouldn't have to go beyond there. Just try and learn them. But, yeah, because it was 6 and 6 is 36, and then 10 and 10. So we then know that b squared equals 256 equals b equals 16. So that tells you the width equals 16 inches, because we're dealing with inches, right? Yeah, inches. Okay. So at this point, we're out of questions.